Okay, so we're going to talk a little bit about rotational motion here. I've taken kind of a wheel here and I've set this container full of water on top of it. And this can be useful because it can show the direction of the acceleration. So every time we have something going in a circle, you can see that the water is dipping down inside there. So it's making kind of a depression in the middle. When water builds up on one side of this container, that is acceleration. So as long as you go in a circle, you accelerate toward the center. It shows it pretty well. What we're going to be looking at here today is basically what different types of acceleration you can have when something rotates. So always when we have a rotating object, we have acceleration toward the center. Now you can call that acceleration AC, or centripetal acceleration. Always every part of the object is accelerating toward the center. So similar to the way that the water built up on the outside, we always have this acceleration. Sometimes they call AC AR, which can create some confusion, but just realize that centripetal and radial really mean the same thing. If we want to figure out what AC is, the easiest way to do it is to take V squared over R. So you take the velocity of this object or that part of the particular thing that is rotating, like for example an object right here. We would then figure out how fast it's going. So you would take the circumference, 2 pi r, over the time. That would give you V. And you would square that and you would divide by the radius, and that would give you the acceleration. Now if you knew what the mass was on the outside of this object, we could then calculate what we call centripetal force. Realize there is no such thing as centripetal force. Centripetal force is just a loose categorization of other forces that act in this direction. For example, normal, friction, spring, tension, etc. And so if we have an object and it's sitting on the outside of a wheel, and you may be wondering, why doesn't this object fall off? Some people would say that the reason is because of centripetal force, but it turns out that that's not the case, that this pen cap stays on this wheel. The reason that this pen cap is staying on this wheel is because in the direction toward the center of the wheel, we have this force called friction. If I put the pen cap on a different part of this with less friction, you can see then it falls off. So it wasn't enough centripetal force to keep it on. Try not to use the word centripetal force if at all possible, as sometimes people will give you a hard time about using it. So that's pretty much it for centripetal force and centripetal acceleration.